Just now. Oh, thank you. So, all right. I think we are ready to get started. Yes. So, welcome everyone. So, and thank you so much for joining us today. No matter where you are joining from, I'm really happy you are here with us. So, before we begin, I'd like to share one thing about today's meetup. So every speaker has their own background, experiences, and way of thinking. So that's what today's sessions are all about. So rather than thinking, is this session for beginners or is this too advanced for me? I hope you will simply enjoy hearing different perspectives. So no matter where you are in your AWS journey, there is always something new to discover. Sometimes the most valuable insights comes from a perspective you weren't expecting. So just relax, enjoy the conversations and the takeaway with takeaway. So whatever inspires you. So, and of course, we love to hear from you. To feel free to share your thoughts and questions in the chat throughout the event. So let's make this another fun and welcoming gathering together. Now let's get started. So just quick introduction. So I'm Hiromi, and together with Yuki, we organize AWS Global Community Gathering. So our goal is simple: to create a welcoming place where people from around the world can learn from each other and connected through the AWS community. So, and if you ever like to speak at the future meetup or get involved, so we'll be happy to hear from you. So now let's meet today's speakers. So we originally planned to have 4 speakers today, but we had a last minute change. So today we'll be hearing from 3 special speakers: Mohammed, Daniel, and Dixon. Thank you. So Amari, who was also scheduled to speak today, will now be joining us at our August next month, so gathering instead. So we will have another great session to look forward to next month. So each of today's speakers brings different background, experiences, and perspective, and I'm really looking forward hearing their talks. So by the way, speakers, if you are already here, could you say hello in the chat or give us a quick reaction? So it's always always nice to know everyone has arrived. So we will follow the agenda shown on the screen, and each session will be about 20 minutes long. So between sessions, we'll have short break while we get ready for the next speaker. So, and as always, feel free to ask questions, share your thoughts, and cheer or our speakers in the chat. All right, let's make it a great event together. And before we move on, just a few quick notes. So you can join us on either Zoom or YouTube, whichever is most convenient for you. So if you share anything on social media, so we'd love to share it. So feel free to use the hashtag AWS Global Community. So, and of course, please keep the conversations going in the chat. Share your thoughts and a question, or simply say hello. Yeah. So just one small favor, please keep your microphone mute during the sessions. And most importantly, let's make this welcoming and respectful space where everyone feels comfortable joining the conversation. So that's what makes this community so special. So yes, all right, let's continue. So before I'd like to share something about this community. So if this is your first time joining us, welcome. So we are really happy you are here. And if you've joined us before, thank you for coming back. So what I really like about this community is that people joining from many different countries and backgrounds. So some people are new to AWS, some have many years of experience, but everyone is here to learn from each other. You don't have to know everything. You don't have to be an expert. So sometimes our simple question starts a great conversation. That's why we are always happy welcome new speakers and new members. So I hope this continue to be a place everyone feels welcome, enjoys learning, and makes new connections. So thank you for being here today, and thank you for being part of our community. So before we move on, here's a quick look at our upcoming schedule. So we will be back again in August and September. So I hope you will save the dates and joining us again. One of the things we care about in this community is giving people a chance to share their ideas and experiences. So that's why we are always looking for new speakers. If you have a project to share something you've learned or a story you'd like to tell, we'd love to hear from you. So you don't need to be a professional speaker. First-time speakers are always welcome. So if you are interested, please feel free to reach out to me anytime. We'd love to have you as one of our future speakers. And one last thing before we again, so if you like to stay connected on the Hear About Future meetup, just scan the QR code, please. So we host we host this gathering every month because we want to create more chances for people to run, share, and connect it with each other. So I hope today's meetup is just the beginning. We'd love to see you again at one of our future gatherings. So, all right, let's get started. Our first speaker today is Mohammed. Mohammed, whenever you're ready. Stop sharing. Oh, they are not? Okay. Okay. Okay, rồi. Và okay. Daniel?
Yeah, I can go next. I can go first.
Daniel, are you ready?
Yep.
Thank you so much.
Cool. I will share my screen, right?
Yes. Yes,
Cool.
please.
Just let me know when you see it.
Yes.
Yep. So my presentation will be about consolidating interface VPC endpoints, and I will share with you how it is from a small account to bigger organization. Just for a bit of background, my name is Daniel Gaina. I'm a AWS engineer. Recent title is like network operations engineer, but I work with AWS and with big organizations. At the moment, I'm working with Aer Lingus as the airline company, and then I'm helping them organize their networking in AWS, which is and hybrid networking because it's spread across on-prem facilities and AWS and different cloud providers and so on. And one of the things I've seen, one of the issues that we have is related to VPC endpoints, but also I've seen that across many different organizations I've worked with in which, they start small with VPC endpoints, but then they end up being everywhere. And then they cost a lot, as you may know. VPC endpoints charge per hour of deployed and then plus the data. So in order to lower the bill, we need to somehow consolidate them. So the reason why it matters, yeah, as I said, is cost firstly, because each of them cost per AZ per gigabyte processed. Consistency, because if we have everywhere VPC endpoints and we deploy it with every VPC, then it's very hard to maintain. Governance, again, like, everywhere we need to have like to be secured and to have policies around them. And it can be very hard to govern them. And then also scalability, like just to have, when you have 5, 10 VPCs is not that much, but when you have like 500 VPCs is a total different story. So scalability matters a lot into this. So this is kind of an example, a bit of how I would say a small scale deployment looks like. So we'll have an account and we'll have a VPC where we have some services like an EC2, ECS, EKS, whatever. And then you have some interface endpoints, some that leads to certain services. So when a service in a VPC access some of this AWS endpoints, it could be two ways. It can either be via the internet, where you could access via the internet, or it could access privately through the AWS internal network, and that is done via the interface endpoints. Some of the companies, they require to go private because they don't want to let the traffic outside and on the internet, so they're doing privately with the interface endpoints. And in here, as you can see, we would have a dev account, a UAT account, and a prod account. Each of them have one VPC, and then each of them will have a different set of interface endpoints. And as you can see here, if we have like 7 times whatever VPCs we have times AZs, then we're already having like so much charges when it comes to this VPC endpoint per hour cost. So duplication, as I mentioned, that cost, operational drift. Sometimes you update certain things on certain interface endpoints or route and so on, and then it just kind of becomes inconsistent between dev, UAT, and prod. Policy inconsistence, DNS complexity, like quite hard to do it at scale. So the more you have, the harder it gets. A simple way to do it is to do it via a centralized VPC. So basically, you would have a VPC in which you put this endpoint, and then you can get the other VPCs whenever they need access to certain AWS endpoints to go via a transit gateway to that VPC, to that AWS service. So this way, you would deploy only once. Instead of in each VPC, you will deploy it once in one VPC, and then this will be, you can access it via transit gateway because it will connect multiple VPCs to your one. So it's many to one type connection. But because VP endpoints are only regional, so then if you would have to have multiple regions, you will need to have one central endpoint VPC in each region, and then you will have multiple transit gateways that connect to each other, and then multiple VPCs that go through that. That could be quite costly. So, some of the details here is that you would have in the spoke VPC, you will have a route that will go to the VPC side range of the central endpoint VPC. In the central endpoint VPC, you would have the endpoints per AZ, and you will also have, very important is to have a Route 53 private hosted zone in which you would have this endpoint's DNS, and then share that, associate that private hosted zone with the workloads VPCs, because this way they will know via DNS how to get there, right? So it's important to have that because otherwise you wouldn't know. This is how it would look, some sort of API call. Then from a workload, they try to resolve KMS, and then they will go to a VPC DNS first, but then they will see the associated private hosted zone. They will respond with the IP address of that endpoint. It will make a call via the transit gateway route to the to the VPC where it's hosted. Then you will forward it, and then you will get the response from the AWS service and back the same way. So DNS is basically important here because, as I mentioned, it's like, if you have a private DNS, you will only resolve inside a VPC. But then if you have it centralized, then you need to have disassociation of this private hosted zone to the other VPC. They're very important. If you do with an on-prem, then you would need to have some sort of conditional forwarding resolver, Route 53 resolvers in order to resolve those IPs. So for example, if you would have some DNS server on-prem, you will need to forward the request to the Route 53 on the AWS, and then it will have to resolve those IPs for your DNS query. The security controls is basically, like where you would have, if you do it at one account level, so you would have this VPC endpoints, you would have you can have endpoint security groups. Basically, you would allow only the accounts and the security groups that you want to access this endpoint and stuff. So you will do it via policies, you will do it via IAM condition keys, or even SCPs to deny certain calls from certain accounts to this endpoints. So security controls are layered, and then they can be very helpful when you have only one set instead of having multiple sets across different environments. So before that, before the VPC endpoint centralized, you would pay, as I said, you would pay per VPC, per service, per AZ, per endpoint hour, per data process, and so on. So that can spread a lot. When you would have it after centralized, then you would have, one service per AZ, per endpoint hour, and you can save a lot of money. Then basically it's just kind of the data that you process, you won't save, because the data that you process through some VPC endpoints will be the same. It will just accumulate, but you will save on the per hour cost. I think that's the more important cost, because when you have 100 is different than when you have 10. So to migrate from this, it's not that hard. So basically, everything works until you switch a route into a route table. So basically, you can do an inventory with AWS config and cost explorer and see how much it costs you at the current state. Then you can pick some VPCs that have very few endpoints, and you can kind of like try to get that to model how it's going to look. You can build a hub VPC, basically the central VPC where you're going to deploy the endpoints for all the services. You create then a Route 53 private hosted zone, and you add a record for each endpoint that you have. And then you share that private hosted zone with the VPC where you want this to happen. And then you just change route on a route table. And then basically now, instead of going via the local interface endpoint, it will go via the transit gateway route table, and it will go through to the centralized VPC, and you can check that via the reachability analyzer. AWS has a service called Reachability Analyzer that can be very helpful for analyzing routes in your AWS account. And you can test that, and once that's done, then you can like decommission that in that VPC, and you can bring other VPCs into it and so on. Definitely is very important to try small, to test for small on a dev, and then just move progressively towards UAT and prod. So some of the risk, as I mentioned, is that even this consolidation, it's done at one region. If your company runs in multiple regions, as I mentioned, then you will need multiple transit gateways that connect to each VPC that kind of share like a sort of mesh type of thing. My last company, they were running in 6 zones, and they had 6 of these VPCs, endpoints VPCs, all connected via transit gateway. There were peered transit gateway between them, and then every service in one region, when they need, they will go to the central VPC endpoint. And this way, we remove the law of VPC endpoints at the VPC level, and we do it in a centralized way. Certain services might require you to deliver differently. So, for example, we would have certain VPCs in which we have EKS cluster that would need to pull a lot of ECR images. On that case, like you can leave some of those endpoints there. So as I mentioned, ECR1, because it can create latency if it does it across. It doesn't create a big amount of latency. However, we did test it that, the more you pull, the harder it gets, the more it takes time to pull those images, especially on a Kubernetes clusters and so on. So it's better on some of the services, especially if they're critical, to leave the endpoints there. As you know, the S3 and the DynamoDB endpoints are free, so those are not really matter. So you can keep them into the local VPC, and that's perfectly fine. We're just talking about the interface endpoints here. So only the one that cost quite a bit. Another thing that I've noticed across a big pattern is that, pretty much all the regions have 3 AZs, right? The difference between having 2 AZs and 3 AZs, it doesn't give you too much in availability. So, but the cost, like if you spread it across, 1,000 VPCs, you'll be, one extra region will be more endpoints. So then some organization deliberately take the risk of running only 2 AZs rather than 3. So, they're okay with the risk that they know that 1 AZ can go down, but 2 AZ to go down, and especially the one they have, the probability is not that high compared to the risk of, 3 and the cost compared to the risk and the cost of running 3 AZs. So, and they just kind of prefer to do 2. So the transit gateway solves the thing at the regional level. However, if you want to do it at the global level even more, like in a way where like transit gateways, you would have to manage the routes yourself. But to go a step even further, you can use a solution like Cloud One, which is like wide area network is a managed solution from AWS that basically gives you a global backbone network. And then it's under the table. It's also running transit gateways uh, which they're peer together and meshed. However, you do not manage the routing. So basically AWS does it for you. So this way simplifies it even more. And then your network becomes more like a policy. Everything gets in code and everything goes into like segments. So you could have different segments for production, non-productions, and so on. And those segments are like their own isolated routing domains where you would just kind of connect different VPCs to it or connect to different network constructs, like even a transit gateway and so on. And then all this, you would have a central endpoints VPC connected to a shared service. And then it's the route to that central VPC is spread across all the segments via the Cloud One rather than the transit gateway, rather than you managing the transit gateway routing rules. So Cloud One does it for you, but it's a higher level construct on top of that. The way it works, as I mentioned, basically you have Cloud One has a construct called core network, and then it deploys in two regions. As you can see here, you would have one in, let's say, US 2, one in EU Central 1, and these two talk to each other and they share routes and stuff. You would have this segments, as you can see, production, non-production share segment. These segments are across a region. So it could be where, in this picture, it's only shows in one region. However, it just kind of like, it goes across the region. You can attach VPCs or transit gateways from any region to a segment. And then you just kind of, what they do behind the scene is just they share routes to each other. So basically they just let everybody know how to get to a certain point. In our case, is to the VPC endpoint thing. So the transit gateway will be, as I said, more like a step one, and then the Cloud One will be more like a step two if you have an organization that's smaller. Let's say, I don't know, it depends. Could be 50 accounts, could be, like depends on your number of VPCs, number of, like connections and so on. But for bigger organizations that run AWS Cloud One, it's more used that way because it's more mature and it's more easy to control via policy and easy to do via then manual tweaking your transit gateways and so on. So it's more the way it run, it's more control like from the platform side, and then you have policy informants. Basically, it's controlled via the networking account. This endpoints VPC will be located in a networking account, and then with Terraform and so on, you can have this deployed very easily to be version tested and so on. You can share this VPC and this like the transit gateway, for example, with RAM, with Resource Access Manager from AWS. You can have a different type of endpoints. You can have different kind of guardrails like SCP to deny any sort of connections. And then the ownership is very important because the way we see things is that some applications team, they do their own VPC and they do their own endpoints and they do their thing, but they might not know how they will only do it from their perspective for their application to work. But at their bigger level, at the corporation level, or like the bigger enterprise level, it's hard for them to see what side array they should choose. How will this play into the whole thing? How will the route be propagated to, and to talk to other segments or to other things? So they might not have this type of information. So that's why network team will be good to own this. if we basically, from what I see, it depends a lot on your maturity level. So as I said, there are companies that they have very few VPCs and they deploy the VPC endpoints at the VPC level, and that's fine. However, if you would, uh, if you end up spending too much and you end up growing too much, it's better to go via the centralized endpoint. So basically having that VPC endpoint, centralized VPC across whatever regions you run, and then all connected with the transit gateway and attached to the other workloads, VPCs that need access to the endpoints. And then if you go even harder, even higher, and you go hundreds of accounts, thousands of VPCs, Cloud One is even better because it helps you with the route management on the transit gateway side. Yeah, some of the sources that I used for my presentation, it was the, AWS white paper, some of the endpoint inventories I check with AWS config, with Cost Explorer to check how much we cost, how much we pay, and so on. And then you can, there's a lot of information out there and there's a lot of articles. I can share some from my own um, from my own repertoire of documents where I'm learning from and where I see architectures references from AWS experts, and then I'll share into the chat. But basically, that's where kind of got our inspiration to go to design this type of architecture. And also, if you thinking of migrating or doing this or proposing this in your own environment, in your organization, just start somewhere small, start testing it and do it one by one. It's easier. And obviously doing it by Terraform, it's even better because it's all uh, easy to maintain, replicable, and so on. So yeah, and I think that's it. Any questions if anyone has? If there's no question or if there's any in the chat, I'll still be in the chat. You can share them there. I'll post my links there and then, yeah.
So thank you so much, Daniel.
Thank you.
Thank you. That was a fantastic session. Thank you for sharing such valuable insights with us. Transit Gateway is an incredibly powerful service. Yes. So with so much attention on AI these days, so it's really refreshing to take a step back and learn more about core AWS architecture, right? Like this. So thank you for sharing your experience with us. Okay, so once again, now does anyone have any comments, questions, and of course thoughts for Daniel? Feel free to ask or share them in the chat. So, oh, okay. So, I love to hear from everyone. So, have you used it VPC endpoints in your own environment?
Were you asking me a question? Sorry.
No, for
Ah,
everyone.
okay, okay.
I think. Yes. Yes, like a big project. Okay, not yet. So, well, it looks like we are having a fuel supplies today. Mhm. Okay. Thank you so much. Thank
Thank
you.
you.
Thank you again. Okay. Oh, uh, you're a nice CRM document. A lot. Wow. Yeah,
Yeah, I shared some of
thank
the
you.
AWS articles and documentation that present also diagrams onto um how they do, just in case people want to read more and stuff.
Mm, wow. Excellent. Thank you so much. Okay, let's give Danielle another big hand. Thank you so much, Danielle.
Thank you.
Yeah. All right, let's bring Mohammed back. Mohammed, are you with us? Not yet. Okay, right. Let's move on to next speaker, Dixon. Hi, Dixon.
Hi, hear me.
Hi, nice to
Hope I
meet you.
pronounced that correctly.
Hi, ready?
Yes, I'm ready. All right. So please confirm you can hear me.
Little bit.
Okay. What about now? Can you hear me now?
Yes.
Okay, what about now?
Oh, good. Very good.
Much better.
Perfect. Mhm.
Okay, okay. Thank you very much for having me. Okay, so I'll be speaking on the topic getting started with Amazon ECS Express
Mhm.
Mode. So give me a moment to go
Okay.
ahead to share my screen.
Yes.
Um, yeah, just give me a moment.
Yeah, take your time.
Okay. Mm. Okay, let me just get started while I try to share my
Mm-hmm.
screen.
Mm-hmm.
So as I said, I'll be talking on getting started with AWS Amazon ECS Express Mode. So ECS Express Mode basically is a service on ECS that allows developers to be able to leverage AWS to ECS to be able to deploy services without having to know all the nitty-gritties about ECS. As we know that ECS, though simpler than EKS, also has some nitty-gritties and some complex sides to it. So AWS kind of created the Express mode to make it easier for a user that has never used AWS or is new to the cloud or new to AWS services to be able to easily use the service to run to deploy applications, right? So that is what ECS Express Mode is used for. Think I would just go ahead to see if I can share now. Okay. I believe you can see my screen now, right?
Yep.
Okay.
I see. Okay.
Okay. All right. So basically, the ECS Express mode allows developers to be able to easily deploy on AWS, as I said earlier, and also allows easy deployment of containerized applications or APIs on AWS. And it's very simple to use, right? And there are lots of benefits of using the ECS Express mode as a developer. AWS kind of simplifies everything for you so that with as little as 10 minutes, you can deploy your containerized application or API without having to know so much about networking, scaling, and so on and so forth, right? So there is simplified deployment, and there is also automated provisioning of resources, and that allows you to also focus on code as a developer. So you don't have to do a lot around infrastructure provisioning. So you focus on your code and AWS take care of the rest. Allows you to be able to deploy production-ready defaults, which you can then customize as needed. You have, for example, in the URL that we provided, you have SSL enabled on that URL, right? And also there is the full power of ECS available, so you can start leveraging standard ECS features. You can start leveraging the ECS features, right? And then you can be able to still you can still be able to grow, right? As needed. You can see leverage other parts of the ECS offerings as the features are released. So basically, ECS Express mode allows you to enjoy the benefit of both worlds, where you are able to focus on your code, and you are also able to get the benefit of the ECS offerings, right? I will be looking at a demo shortly. So I'll just reshare my screen. So in our demo, there are some prerequisites, and one of it is that you need your Docker image, right? It can either be on Docker Hub, or you have it on Elastic Container Registry, this ECR. So any of this, you can have your Docker image there. Obviously, you need an AWS account, right? So your image is an ECR, and with that, you can move on to deploying on ECS Express mode. So without wasting much time, I'll just go ahead to quickly reshare my screen so that we can go ahead to start the demo. So I will just reshare my screen here. Please confirm you can see my screen.
Yes, we can
All
see
right.
it.
All right, great. So here I already have so let me just, by the left-hand side, you find the Express Mode button there. Just click on it. Meanwhile, I already have my my Docker image in ECR. I named it Texting Friday. That's the name of the repository for my Docker image, my ECR repository. So I'll just go ahead to choose the Docker image. I already have it in ECR. I will share the GitHub repo I used for this. The GitHub action script is there. So you can also use it. So I already named it. So here I'm choosing the repository, right? Choosing the repository. I'm using the latest, the image with the latest tag, selecting by tag, right? Image tag latest, and that is it, right? But if your image is in Docker Hub, for instance, you just have to provide the save it in secret manager and then provide the ARN of the secret manager here. But in our case, it's in ECR, so we already have that there. Next, you provide the task execution rule, right? And that is already kind of gets populated for you automatically. Meanwhile, you can also click this button to create it. So I already did that before, so that would be automatically imputed here. Yeah, that will be imputed here automatically. Let's just go on. The next thing is you can either just click create and it will use the default values, right, that are already specified by default. Else, you can go ahead to click on additional configurations to be able to like do some customization, right? So in our case here, we want to use we already have a cluster created test cluster created, which I've already chosen that. My container will be running on port 3000. The health check can remain at the default. And if you have environment variables that you need to, that your container works with to be able to run successfully, you can import it, do bulk import from secret manager or parameter store, or you can manually add them as environment variables here. But in our case, we don't need to add any environment variable. Here, we have the command section. If you need to pass migration scripts or some custom commands, you can, use this part to override the CMD command in your Docker file, right? So this is where you can pass the database migration scripts that the application needs or uses. So here, next we have task row. So you can specify the task, you can create a task row that allows your container run your tasks, right? It allows your tasks to be able to make calls to AWS services or that grants access to AWS services such as S3 bucket or SNS or other AWS services. So if you need your tags or your container to have access to those services, you simply create a task row and then specify the task row here. In our case, we won't be needing that, so I won't be creating any task row. Meanwhile, that is different from the task execution row we created that was earlier specified here. Okay, just choose this. All right, so next here, we'll go to compute. So under compute, you can specify the size of compute you want. You can start, in my case, I'll start with the lowest 0.2 vCPU and 0.5 GB of memory. Then for auto scaling, you can scale the several options here, 3 options. We have the average CPU utilization, right? So if you need to scale based on average CPU utilization, you just configure the values here. There's also the option for average memory utilization and as well as request count per target. So in our case, we'll leave it on default, which is the average CPU utilization. The target value remains, let's leave it as 60. Minimum, let's just leave the defaults as was earlier specified. Here in this case, we just say 70. Scaling based on average CPU utilization, and that is the default. Also, in terms of networking, if you want it to be deployed in the default VPC, you can ignore this networking part. But if you want to deploy in a custom VPC, you can click the button, specify your VPC. In my case, I want to deploy in VPC already created here. And subnets, I want to deploy in the public subnets, specify 2 subnets minimum. And for logs, the CloudWatch log group will automatically be generated from the image URI. You can also specify a name for it here. So that was pretty it, right? So then you go ahead to click the create. So all this are what you just specified, and with this, AWS will go ahead to begin to create the resources in the background, or the resources that are needed for your application to run successfully, right? At the end of the day, you have an application URL here, which you can click on and you can access your API or your application. So as you can see, the resources are being created, including the tax definition, metric alarm, ingress paths, certificates. All these are being auto provision, the load balancer, security group, as well as the load balancer, and so on and so forth. So all of these are being created, right? So it will take about 5 minutes or thereabouts for that to complete creating. So basically, these are the resources are being created, right? So you have the ECS cluster. We already have an ECS cluster that we're using. You can also create another one, right? The ECS service is already being created and in the background, right? And that is a Fargate tax, an ECS service with Fargate tax. So Fargate is the underlying service that is going to be running the application, right? And not the EC2. So that means AWS takes care of the management of the underlying resources. In this case, Fargate. A load balancer with health check is also doing provision as well as auto-scaling policies, which we have specified. In our case, we specify average CPU utilization, as well as security groups, networking configuration. There will also be a custom HTTPS URL that have been generated for us, as well as the CloudWatch log, right? So it's as simple as that, with just a few parameters. We'll have our API or application up and running on ECS. So just a side note, ECS was what AWS recommends. So recently, AWS ended support for App Runner, and AWS then recommend that all existing or all new App Runner, all customers that currently uses App Runner should migrate to ECS Express mode. That's as an alternative, right? So our resources are almost completed right now. The service it's being created. So we can click on the application URL here. Okay, application is not yet ready. Just give that a minute or more. So a service is still in deployment is still in progress. Just give that a few more minutes. That will be and that should be completed in a few more minutes. Let's just have a look at that. So it's currently activating. Our task is currently activating. So just a minute or two. Okay, now it's running. So let's go back to our URL and refresh that. Okay, still coming up. Let's just give that. Okay, so you can see. Please confirm you can still see my screen. I have my application up and running now. Can I get like a thumbs up or just to show that you can see my screen? All right, great.
Yes.
Yeah,
Yes.
so great. So as you can see, with just a few steps, I have been able to deploy my application on ECS, right? And all this comes with a load balancer, right? In the background, I have a custom URL that is SSL enabled, right? So with this, makes it very easy for developers to deploy the containerized applications or APIs on AWS. So that's basically it, talking about ECS Express mode. You can see resources are completed creation. You can see the logs. You can easily see the logs from here, and you can see the logs. You can also see it also comes with observability. So you want to see the number of error, 404 error or 504 error, like all those observability metrics. You can also see that in a single pane of glass right here. So that is basically it. It's very, very simple to use, right? So my time is up. So basically, to so save on costs, just because since this is a demo, to delete the resource is very easy. So clicking on this button, delete service, we automatically delete all the resources that have been created here, right? So this URL, as you can see, is live, right? It's live. Yeah, can also share that on the chat so you can just have a look at it. And I'll be pulling that down in about 5 minutes. Yeah. So as I said, if you need to delete the service, just click on delete service and everything it's going to be deleted automatically. All the resources are going to be deleted automatically. So any question, I would like to entertain questions at this point. Yeah. Is there any question from anyone? Okay, can have a look at the URL here. So if you have any question, go ahead to ask your question. I think that'll be all from my end. Meanwhile, you can also connect with me on LinkedIn. I will drop my LinkedIn link here. Yes, thank you very much. I will be dropping the GitHub repo on the chat as well as a post. As well as this a link to the slides. Yes, thank you very much for having me.
Thank you so much, Dixon. That was good session. Great. Thank you so much. So, ECS is one of the core AWS services, and I'm sure many people here are already using it in their own environments. Yeah. So, and I have to say your slides were about adorable. Yeah. So I really enjoyed them. Thank you so much. So, and thank you for the live demo as well. So it was great to see everything in action. So once again, does any have any question or comments or thoughts for Dixon? Feel free to share them in the chat. Not comments? Oh, thank you for sharing the GitHub and social links and document. Thank you so much. Okay, thank you. All right, let's give Dixon now a big hand. Thank you so much. Thank you. So,
My pleasure.
thank you. Great speaker. Thank you. So, all right, normally Mohammed would be joining us next. So, but unfortunately, it looks like he wasn't able to make it today. So we had a bit of a change to our schedule. So sorry. So even so, we have had two special sessions today covering two important AWS topics, VPC endpoint and Amazon ECS. So if today's session sparked your interest, I'd really encourage you to explore the AWS documentation, white papers, tutorials, and hands-on labs. So there are great way to drive even deeper into these services. Yes. So, all right, everyone, we've come to the end of today's gathering. Uh, so sorry. Um, I don't have presentation today, thank so sorry. So before we finish, let's give all of our speakers another big hand. Thank you so much. So I hope you are leaving today with something to take home. Maybe a new idea, a new connection, and of course new services. So our fresh thoughts of inspirations. Yeah. So even so, today's event was a little shorter than usual. It was wonderful to see so many familiar faces and also welcome some new ones. So if you'd like to stay connected, please feel free to share your social links in the chat before you leave. So that's what makes this community so special. So every gathering is a chance to learn from each other and meet people from around the world. So, and don't forget, we'll be back again next month. And we'd love to see you there. Until then, take care and enjoy the rest of your day or night. Bye, everyone. Thank you so much. Thank you so much. Ooh. Thanks, everyone. Thank you. Thank you anytime.